Alright, welcome back everyone. Let's go over some questions to see if you're ready for chapter 2. As per the last time I did this, I'll go over questions with the times and then I'll go over the answers. So question 1. What property or properties does each subatomic particle help determine? 3 minutes, and if you can't solve it, watch the first content video on this playlist. Question 2. There are two stable isotopes of gallium with masses 68.92558 and 70.92470 AMU. If the average atomic mass is 69.7231 AMU, what is the percent abundance of the heavier isotopes? 5 minutes, and if you can't solve it, watch the second video on periodic tables. Question 3. Fill in the missing information about the 4 nuclides on the table. Each column contains information about one nucleide, 6 minutes, and video number 1. Question 4. Give an example atomic symbol and name that satisfies each description. 3 minutes, video number 2. A student writes the following on an exam: an ionic compound is when metal bonds to a nonmetal. Explain why this statement is not completely correct and only receives partial credit. 2 minutes, video number 3. What is the charge of the cation in compound Cr2O3? 1 minute, video number 3 and 4. And briefly explain why each name and formula combination is incorrect. 3 minutes and also video number 4. Okay, so solve these within the time, and if you can't, go watch the videos. So for the answers now. Number 1. What property or properties does each subatomic particle help determine? So the first step you want to do in this question is find out what subatomic particles we have. And the three subatomic particles are electrons, protons, and neutrons. Now, protons determine the identity of the atom, which is basically which atom it is, the element. The neutron determines the isotope of the atom, so like which flavor of the atom we're looking at. And the electron determines the reactivity and the charge of the atom. We'll get into reactivity in a future chapter. And charge, although it's based on proton and electron difference, proton's identity, so if we keep that same, electrons determine the charge. Now, the next question we're looking at is there are two stable isotopes of gallium with masses 68.92558 and 70.924705 AMU. If the average atomic mass is 69.7231 AMU, what is the percent abundance of the heavier isotope? So let's set up a variable x as the abundance of the heavier isotope. And so if we want the abundances adding up to 100%, which is how we should have it, the lighter isotope must have an abundance of 1 minus x. And that gives us with the equation that average mass equals isotope 1 multiplied by abundance plus isotope 2 multiplied by abundance. So here we have the average equals 69.7231 AMU, and that equals 68.92558 AMU multiplied by 1 minus x in parentheses plus 70.924705 AMU multiplied by x. And solving this all out, we get x equals 0.398935 times 100%, which equals 398935, which also equals 39.89%. Okay, so the next question. For this, we need a periodic table. We start out with aluminum, which is the 13th element, 13 protons. So if the mass is 27, that means 14 neutrons, 0 electrons because the charge is 0. 42 protons for the next one, that's MO, 56 neutrons, so the mass number is 98, 42 plus 56. Plus 2 charge, which is basically the difference between electrons and protons, so we got 40 electrons. So we write this as 98, 42, MO, 2 plus. Next one, 57 electrons plus 3 charge, that means 60 protons, mass number 143, that means 83 neutrons. We would like to write it as 143, 60, Nd plus 3. 92 protons, 95 electrons, so negative 3 charge. Mass number of 238, so 146 neutrons. We want to write it as 238, 92, U minus 3. Okay, next question. Give an example, atomic symbol, and name that satisfies each description. So halogens, we got fluorine, bromine, chlorine, or iodine, which is FbRcl or I. A transition element in the fourth period, we got SC scandium, TiV, Cr, Mn, Fe, Co, or Ni, Cu, or Zn. A lanthanide element, so LaCePrNd, PM, SM, EU, GD, TB, DYHO, or ER, TM, YB, or LU. An alkali metal, LiNaKRb, CS, or Fr. A metalloid or semimetal, BSiGeas, SbTe, or At. And finally, a noble gas, HeNeArKr, Xe, or Rn. Next question. A student writes the following on an exam. An ionic compound is when metal bonds to a nonmetal. Explain why the statement is not completely correct and receives only partial credit. This is going to be a very common pattern that the student's explaining, metal plus nonmetal, but we reach into an exception, which is ammonium. So in other words, an ionic compound is a compound held together with ionic bonds. The attraction between full plus and minus charges on ions. The statement receives no credit because the person writing it defines the ionic bond and thinks it's type of an element, basically a metal or a nonmetal, rather than an arrangement of electrons. Okay, so what is the charge of the cation on Cr2O3? We got an oxygen, which is -2, so 3 of them, which makes -6. 2 chromiums, so the charge of the chromium is +3 since it's a neutral element. Now, briefly explain why each name and formula combination is incorrect, which is going to be sodium sulfite Na2S. So this is sulfite, not sulfide. Sulfite is a polyatomic for SO3 2-, so it's Na2SO3. Calcium carbonate, basically the formula is incorrect. You only need like one carbonate, CO3 2-, to balance the 2+ charge on the calcium. We got nitrite, which is NO2, but in this case, the name and molecule don't match. Nitrite is NO2-, and this is basically neutral, so which we have here, NO2, that's nitrogen dioxide. Iron 3 oxide, FeO, it's basically iron 3 oxide, so that means we would have Fe2O3, not FeO. And monocarbon monoxide. Don't use mono before the first element. This should be carbon monoxide. Okay, cool, that is all. Make sure you can solve all of these, and happy studying.